This is LED technology. There's about, in this unit, I believe there's 1,200 LEDs. It's a bicolor instrument, so it's daylight and tungsten instrument, and it's capable of blending both of those color solutions together to give you a range of different choices. For instance, I'll show you the way we control that. I've got a little controller here. The nice thing about this fixture is it's using a technology that has been developed for commercial applications. One of the first things that they're going to look at doing, if you do any night photography, if you go to downtown LA and you look, a lot of the buildings have lighting that stays on all the time. Each one of those offices has X number of watts of burning power. They've gone with fluorescent in the last 20 or 30 years because that's more efficient than regular tungsten lighting, but even the fluorescent is using a lot more power than the LED technology. So one of the practicalities of, or one of the civil uses of this technology outside of motion pictures would be to take LED panels and start replacing the commercial fluorescent fixtures in a lot of these office buildings. So these engineers took that technology and they started creating shapes, and we said, well, let's see if we can control the CRI, the color rating index of your output. Let's see if we can get it into some usable thresholds that we want for motion pictures, which would be your daylight application and your tungsten application. So we played around with that and we came up with something that is giving us pretty decent control over how we want this color to look. Okay, this is a full tungsten. The reading out of here, if I were to put my color meter on it right now, would be somewhere around 3,000 degrees. Okay, spot on tungsten, we're talking about 3,200 degrees Kelvin. Okay, the minute I jump into a mixing scenario, you see that little pop? Now I'm into 3,200, and as I go further down the dial, I start mixing my sources of LEDs inside. And it's basically crossfading the 5,600 Kelvin LEDs with the 3,200 Kelvin LEDs. And I can take this any degree I want, from full tungsten to full daylight. You'll see another pop. That's how I know I'm in full daylight. And that is about, with the color meter, I've tested this at the shop, about 5,800 degrees Kelvin. It's a tiny bit bluer than true daylight. Okay, it gives us a little bit of that option. If you shoot outside, sometimes you'll notice even in full daylight, you may get a mixture of over predominant daylight value. But you may notice shadows are a little bit bluer, a bit higher in Kelvin temperature. So we want to go just a bit higher than 56 to give us a little bit of extra blue for those types of applications. But I kind of like it somewhere in here.
When you said crossing the RGB, right?
Mm-hmm.
Basically, so those three colors.
No, these are not RGB. These are true 3,200 and true 5,600 LEDs. Yes.
So they've done away with that, with the old model of like.
Some companies are still doing RGB.
Okay.
Okay. Some of the companies are. It's a less efficient way to master the color, because the RGB output is a lower wattage, and of those LEDs, those lower wattage LEDs can only be driven with a certain amount of power.
Gotcha.
These are what, inside this unit, are what are called surface mount LEDs. In other words, the driver and the circuit component of the LED is actually hard mounted to a circuit board. And then the diode is hard mounted alongside the driver and the printed circuit. Okay, and those LEDs are phosphor, true daylight, and true tungsten.
Cool.
So what's the life cycle of the average light system?
The life expectancy, and it has to be interpolated in a lab, is 60,000 hours for these LEDs. In other words, the lifespan of this light, maintaining its integrity over time, would be 60,000 hours, which is, if you burn that light 12 hours a day, 2/3 of the year, so for maybe 300 days a year, that would last for 30 years.
Just for as a reference too, a tweenie, which we'll show you, the life expectancy of a globe is 30 hours. So 60,000 hours versus 30 hours.
And a tweenie can't do this. Daylight, tungsten.